Okay, so I got a heads on, so we can start. Hi everyone. Thanks for having me at Codemotion. My name is Kuba Waliński. I'll be talking about functional programming in JavaScript. Those of you who have just seen the Kevlin session are well introduced to the subject. I will have a short introduction to functional programming as well for the ones who just came in. If you like this talk, if you want to talk about it more, you can reach me on Twitter at Kuba Waliński. You can email me. You can read my blog. You can have a look at my GitHub where all the material from all my talks are. I do some other interesting talks as well, so you might have a look and see if there's something that interests you. I work for ABB. I'm from Poland, and I'm generally originally a C# developer, very much involved in the object-oriented world. But the past few years I've been doing a lot of JavaScript, and through JavaScript I discovered the wonderful things of functional programming that you probably heard of and want to hear more. So I'll tell you more about it today. So, functional programming. To quickly reiterate, because Kevin has done a fantastic job explaining, but let me offer my own point of view on this, and then also I will relate those concepts to JavaScript. First of all, the most powerful thing is the function is your first-class citizen in the language. What that means is that a function is a thing, as Kevin said, and can be stored in variables, it can be passed to other functions, it can be stored in data structures. When you pass a function to another function and you return a function from a function, you have what you call the high-order functions. So functions who operate on other functions. This is also very powerful, and I'll show this to you in the demo, how this can work in JavaScript, and it works really well. And you can do really powerful things with this approach. Functions should also be pure. This one you can really make use of the functional programming concepts. And a function is pure, meaning that every time you give a function a certain set of results, because there are no side effects and nothing else is affecting how the function works, so if you give it two elements as inputs, it will always produce the same results. So this basically, in practice, it means, for example, that if you have the same function in your program called with the same parameters a few times, you may do the execution once, store the result, and just use it anywhere else, because you know that it's not going to change. Then again, pure functions are also independent of other functions. So you can run one pure function in parallel with the other, and you know there's no state change, so no problems, no locking. And also the function has no side effects. So this is a very good area where your compiler can do a lot of optimizations. Again, no side effects, no state change. So everything is simple and nice. Another fundamental concept for functional programming language is immutability, which I just expressed in pure functions, why it's so important. So you have state, you shouldn't change it. If you need new data, you just create a new element, create a new object. Don't change the one that you already had, because you're going to introduce problems down the line. And finally, recursion, as you probably all know, fundamental thing for functional programming. And while you're doing recursion, it's pretty dangerous, because you can run out of memory for your stack. When you keep stacking your calls one on top of the other, you can get the Stack Overflow exception. That's why it's important to have tail call optimization, which is a technique where instead of putting new calls on the stack, the compiler knows that it's a recursive call, and if it's composed correctly, it can optimize it to a loop, basically. Then you will never get the Stack Overflow exception in that case. So that's the very brief introduction. And now let's see, how does that really apply to JavaScript? Because it might be surprising to some of you. So first-class function, yes, of course. Fortunately, JavaScript basically was one of the first languages that many people started using that had that. And closures as well, and lambdas. And actually, that's about it. Unfortunately, what we have built in, closures is when you can have a private state in a function that's already been executed, and it has some data that only this function can access, and nobody else can change it. So it plays well with immutability. And lambdas is basically where you can define a function in place without needing too much additional boilerplate code. And you can treat a function as a thing that you can use and pass around. So that's what you get from JavaScript out of the box. Then you can obviously also use pure functions and immutability, but it's that's your responsibility to take care of. You have to make sure that the functions you write are pure. There's no support from the language. There's no compiler, obviously, in JavaScript because it's interpreted. That will take care of this. And the same with immutability. But you can stick to this. Unfortunately, you can do nothing for now about tail call optimization if you want to use recursion. But it's hopefully going to change soon because JavaScript is evolving and it's supposed to come in the future version. Okay, so that's the theory, and now I'll show you some demos. Can you at the back see the code, or should I make it bigger? It's okay, cool. Okay, so this is Functional Programming 101, and I decided it will be nice to greet all of you, but I'm going to do it in a functional way. So I will define a function that concatenates two strings and puts a space in the middle. Obviously, I could do A plus space plus B, but I want to be functional, so I'll put them in an array and use a join function on this array and join them with a string. And also, I'm trying to prepare some ground for the demos that will come next. And in the next demos, we'll be doing a lot of flipping of arguments. That's why I created the function that flips an argument, and it takes a function, a first and a second argument, and then it executes the function with the arguments reversed. So combining those two, I pass in Rome hello, and actually what I'm going to get is an error, because it's a different directory. And an error again. Yeah. So what I'm going to get is hello Rome, because the arguments have been flipped, and there is a space that's been put in between of them. So that's the initial demo. And actually there's one more. Now I'm going to show you an example that we'll be working on for a few other demos. So this is some code. It's very simple, 10 lines of code, excluding the comment. But I don't think most of you would know immediately what's happening here. You have to read through, you have to put it in your head that there's a for loop, there's an if, something's happening, something's changing. But really, this code just goes through an array and makes sure that all the items are negative. So if it's non-negative, it gets multiplied by -1. So a pretty simple thing, but in procedural code that we would usually write, it's confusing and you probably need a comment somewhere if you want the people who read it to get it more quickly. So I've created this function, and it's going to be our benchmark, and I'll try to implement the same functionality in a functional way, in a few different ways. So the first approach is in vanilla JavaScript. So pure JavaScript with no additional libraries, stuff that you all have in your browsers and can use right away. So I'm including the function that I've just shown you, because I will be later comparing the results. It's called the doSomething function. And now I will try to do the same functionally. So to do that, there is a basic, I think most rudimentary function, and we operate on arrays in a functional way, which is called map, which just takes a function and executes it on each element of the array. And we already have this in JavaScript, but unfortunately it's attached to an array object. So as long as you have an array, you can call it dot map and pass a function that you want to use. But I want to combine this function with some other functions, so I want it to be disassociated from the array object. I want it to be independent. So I'm just in this line, I'm basically making it independent. So I'm defining a new function that takes an array and a function that is supposed to be mapped and just calls this map on this array. So once I have that, I have made really a problem for myself here, because that's the standard order of arguments that you expect in a map function in most languages. So the array goes first, and the function goes next. And what I would like to do really, as it's mentioned in the comment there, I want to do a one-liner. I want to compose a function that takes one line, and it actually waits to get the array at the end. So I need the array to be the second argument, because I'll pass the first argument, the function, beforehand, and then we'll be waiting for the array to operate on, already having the function composed inside. So I need to flip those arguments, and that's why I've got a flip function. And as you can see, it's pretty straightforward. It takes a function initially, and then takes arguments a and b, and applies them to this function in an opposite order. So examples here make pretty sure what's it all about. You divide 1 by 2, you get 0.5, but when you flip the division, you get 2 divided by 1, which is 2. So pretty simple. By the way, I forgot to mention, but if you have any questions during the talk, just raise your hand and we can talk. Don't keep it till the end. So now another thing that we'll need, another building block, and another interesting concept in functional programming, which is carrying. Meaning that if you have a function that takes n arguments, you can pass them one by one in any order until you reach the n element. In this case, I've prepared a carry function for 2 arguments. So it takes a function at the beginning, and we know that this function takes 2 elements. Then it takes the first argument, returns the function that takes the first argument, returns the function that takes the second, and only once it's got both arguments, it applies them to the function that's been passed at the beginning. So I need this because, as I mentioned, I want to use it on the map function. First pass in the function that's supposed to run on the array, on all of the elements, and only then pass the array at the very end. So an example of carry function, when you have an add function, the basic one, you can define a function that already has 3 in, and you have a function that is waiting to add something to 3, and when you add 4 to it, you get 7. So it's a pretty simple concept, but again, as you will see in a moment, pretty powerful. And finally, some final bits. I need the helper functions to negate and extract an absolute value from the elements of the array that I'll be working on. So obviously I first need to do the absolute value and then negation to make sure that the output is always negative. And to do this, to compose those 2 functions, negate and absolute value, I will need a compose functions. Compose function, which is pretty simple, takes 2 functions, f and g, waits for the argument that it's supposed to work on, and then applies them. First applies the function g, so the second one, as you can see, and once this is computed, it passes the result to the function f. So in this case, let's see the example. In this case, I have a function that greets by adding chow to the beginning of the string, and I have a function that exclaims by adding the exclamation mark at the end. And obviously, when I compose them and pass in Rome, I get chow Rome with an exclamation mark. And that's how it works also with the negate and absolute value. In the case of this, in the case of the example that I've been showing at the beginning. So this is my implementation in a functional way in vanilla JavaScript, no additional libraries, everything that's already in the language. So we're starting up with a map function, obviously, because we need to operate on the array. But as I mentioned, the order of arguments is not the one that we're looking for. So we're flipping the arguments of the map function. And we're also running a carry function on it. So the map function now is waiting to get a function that is supposed to be executed on each and every element of the array. And the array will come in next. And the function that we pass that is supposed to be executed on every element is a composition of negation and absolute value. So it might not look simple yet, but bear with me. The other examples will be simpler, but well, there was 10 lines of code before, now we have 1. So we're already getting somewhere. And we have some test data. I will now execute this code, and we'll see if we get the same results for both cases. Yeah, so you can see we've got some test data, and the result of running both functions is the same, and all the numbers are negative. But I would argue that when you get some, it takes some getting used to getting grasping the functional programming concepts. But once you're used to them and you see the carry, map, and flip, and compose, you immediately know what's happening. And it's just one line of code, so it'll be easier, I think, to comprehend than the previous code. I mean, than this code at first glance. So this was a demo for vanilla JavaScript, but fortunately we've got some libraries that will make it even easier for us to code in a functional way. One of them is LoDash, which is basically a port of underscore, which you might have heard about, because it's very popular. The name comes from the underscore character that you use to invoke all the functions that are inside this library. It provides lots of useful functions, not just for functional programming, some of the ones that I'll be using in the demo, but generally a lot of useful functions if you're working with arrays, collections, functions. Basically, it's a tool belt that every JavaScript developer should have in their project. So if you're not using it, I recommend that you have a look, because you're bound to find something useful in there for every use case. So let's have a look at the code as implemented in LoDash. We'll load LoDash from npm, from the package manager. Again, I will require do something function, and I have the negate and absolute value that you've already seen, that are the actual building blocks of the functionality of my function. So now with LoDash, we've got a few good news at the start. I don't need to specify a carry function because it's already in LoDash, so I can partially apply the arguments to my function. I also don't need a compose function, it's also built in. Unfortunately, there's no flip function, but there is a nice combination of carry and flip, which is partial right. Partial right means I'll be applying arguments partially, but from the right. So it's exactly what I need, because I first, as you remember, the map function first takes the array, then takes the function, and I want to pass the function first. So if I use partial right, I'll first pass in the function, and that's exactly what's happening here. I have the map function, and it's passed to partial right, and then I pass the first argument from the right, which is the function, and again, it's composition of negate and absolute value. So as you can see, thanks to the tools that we have in LoDash, the code is even more simple now, even easier to understand and reason about. And again, I have the same test case, and I'll run this code, and we'll see what we get. Again, we get the same result, with even more readability for the programmer. Because in the end, I think that the fact that the code does what it's supposed to do is one thing, and that's usually what we focus on, but we forget to focus on the fact that our code also has to be readable, and somebody has to maintain it later on, probably us in 2 years, when we don't even remember what this project is about. So it's at least as important, if not more important, that the code can be easily understood, because it's been said, and I think I would agree, that we as programmers, we spend more time reading code than actually writing it and trying to understand what's going on, to know where to put the change. So just, if not as a favor to other people, but as a favor to yourself in 2 years, you should make sure that your code is actually easy to read and you know what's going on. And I guess here you can immediately see what's going on. On that note, one funny story. or anecdote that I heard is that you should always write your code as if you knew that the person maintaining it is a psychopath that knows where you live. So that's something to keep in mind, and it really puts that into perspective. And finally, a final approach with a dedicated functional programming library that I found on GitHub. It's created by a guy called Lee Crossley, a very interesting guy, because I've been contacting him asking about the library. So he said that he's constantly developing and using it, over 100 downloads on NPM, etc., etc. Obviously not that impressive, but you can see that it's a tool that's working for some people. He says that he's using it on his projects every day. I've also really started to like the library. I'm using it a lot. I'm also contributing to it on GitHub because I found a few bugs. Actually, one of my demo, the first version of my talk, the demo failed because there was a bug in the library. But then I submitted a pull request and now it's fixed. So today, everything should be okay. So here now we have the code for FunctionalJS. So again, importing the stuff that I need. And there is a carry function which behaves exactly the same way as the simple one that I was showing you in the first demo. So you can create a function that already remembers 4, adds 5 to it, prints 9. The carry function is pretty cool here because you can pass as many number of arguments as you can. So to this function add to 4, you can keep adding, and there's no limit to 2 elements like it was in my previous naive implementation. But even better news is that basically all the functions in this library are carried by default. So when I have a map function, I don't need to call carry on it because it knows that it can accept those parameters one by one. And also the order of the arguments for all those functions is correct from the point of view that they are taking the function first and then the array, or basically the data that they are going to be operating on. So a lot of headaches are out of the picture when you're using a dedicated library that's focused on functional programming like this. And again, compose function is also present, as you'd imagine, and works basically in the same way as my previous implementation in vanilla JavaScript. And we have to remember, as you've seen before, that the order is important, because if you apply incorrectly, then it will print a positive, not a negative number. Just a reminder. So, knowing all that, this is what I came up with when I wanted to implement this functionality in FunctionalJS. And I don't think it can be any simpler. We're basically at the point where we just have a map function that we know maps a function to an array, and we pass a function that should be mapped, which is a composition of negate and absolute value. And that's it. And we'll see how that works. And again, results are correct. My pull request obviously has already been merged. And so I can recommend this library if you want to explore some more functional programming features in JavaScript. There'll be links to all those tools that I use at the end of the presentation in my slides. If you're interested, you can have a look. Especially FunctionalJS is a very good website, and on the website you can go through a tutorial and see the most interesting things one by one and figure out how you could use them in your own project. And finally, something I mentioned at the beginning, JavaScript is constantly evolving, and this year we're supposed to see the finalization of the ACMA Script 6 standard, and hopefully it will be available in browsers by the end of the year, or maybe next year. And it brings a few interesting features that we can use. 2 of them are strictly related to functional programming, like arrow functions, which is just a simple way to define a lambda, and I'll show it in a moment. And tail call recursion that I mentioned, that so far it's not present, and you can basically blow up your stack if you do recursion wrong. But JavaScript engines will have tail call recursion built in when they implement ECMA Script 6. So that's very good news for functional programming. There are also some interesting features that are not strictly related to functional programming, but they're so cool that I just wanted to show it to you guys. And it's destructuring arrays, spread operator, and rest parameters. I know those names don't mean anything to you. That's why I'll be showing the code to show you what exactly I have in mind. So a brief word on my setup as well. ECMA Script 6, as I mentioned, is not yet finalized. It's quite difficult to find an environment that executes this code correctly. But there are some tools that can compile or transpile the ECMA Script 6 code to ECMA Script 5 that you can actually run. And that's what's happening here. I have 4 examples for ECMA Script 6, but they are all transpiled on the fly by Google Tracer, which is a tool that can do that. And the compiled file are just placed somewhere in my folder. That's why I can show you ECMA Script 6 code, and I can show you how it would run. Okay, so arrow functions, as I mentioned, just a lambda. So you define a function square just by using the arrow operator, and you say that it takes x and it returns x times x. So pretty simple, but uses much less space, and it's more concise and doesn't create any additional unrequired noise in your head when you're analyzing the code. Because in current version of JavaScript, you'll need to write function, then an empty x in the parameter list, open brace, return x times x, close brace. So you're saving a few lines, and you're saving some mental capacity as well when you analyze. So when we run this, we see we've got console log of the execution on 1, 2, 3, 4, and we get 2, 4, 6, 8, all the elements doubled. We've got the actual square, and we have a confirmation that it's a function, and we've got square of 4, which is 16. So all as expected, although it looks much nicer and simpler. Now then, I also mentioned on my slide tail core recursion, but obviously this is not available yet, even if you use Google Tracer or some other transpiler, because this is something that actually has to be built into the JavaScript engine. And it's not present in Node yet, that's why I cannot show you, but it will be there once they get to it. Node is already implementing some ECMA Script 6 features, but tail core recursion is not on the list yet. So instead of this, I figured that I will show you those other few features that caught my eye, that I think seem quite interesting. So first of the feature is destructuring. And basically, it looks weird if you're familiar with current JavaScript, but it does exactly what you would expect. So you have an array with 1, 2, 3, and you want to take some elements from those array into separate variables. So you just write first, second, third in an array notation, and the 1, 2, 3 will be put into first, second, third, which you will see in the moment. And you can do the same with objects, as long as the name of the properties. No, actually, yeah, as long as the name of the properties match what you're trying to assign to, you're good to go. So let's see how this works. No, not here. Let's see how this works. Yeah, so you can see first, second, and third. When we log it, we get 1, 2, 3. And X, Y, Z, we get again 1, 2, 3. W is here, but we didn't ask about it, so it's ignored. And missing is not here in this object, so that's why you get undefined. So that's pretty cool. So also, we've got the spread operator, because often it happens that you've got data in the form of an array, but then you need to apply it to a function, and the function is not expecting an array, but wants the arguments to be passed one by one. So that's a problem, and then you had to write some code on the spot to figure this out. But now if you have a function that takes 3 arguments, for example, and adds them together, instead of passing them one by one, you can just use the triple dot operator, which is the spread operator, and you can spread this array and make sure that it can be accepted and processed by this function. And as you can see, it prints 6, 1 plus 2 plus 3 as expected. So basically some syntactic sugar that will save you some time when you reach this edge case. And also, once JavaScript programmers get used to this, because at first I think they'll be scared and they will not understand what those 3 dots mean. But once we get used to that, I think again it improves the readability of the code and makes our lives simpler. Okay, and now my final demo. To kind of puts it all together, because I'm using the arrow functions and the spread operator, and I'm introducing another use for the triple dot operator. The premise here is that we want to write a function that first takes basically logs something, but first takes the tag, a tag like info, so the level of the log that should be applied to each entry, and then takes an unlimited number of other parameters that are just logged after the tag in a separate line. And to do this, I have an array that will be spread using the spread operator, and the tag is info, and then I have 4 messages: booting up, ready, invalid login attempt, and shutting down. So this is how we do it in the current JavaScript version, in ECMAScript 5. We can pass in the tag as the first parameter, and the other parameters are also there, but they're not listed here. But we can get to them through the arguments object, but we have to start at index 1 because the first element is already taken care of here. So we have all the list of all the logs that we want to log, and then we call a for each function on this log array, and we print the tag, colon, and we print the log. So for each log we'll get a line with the tag first, and then the log that was passed. And I execute it with the spread operator with the array that I've been showing you before. So that's nice, but also not immediately visible what we want to achieve, I guess. So this is how we can do it in ECMAScript 6. Again, we specify the tag, and then as many parameters as there are, they're all going to be put into a logs array. So basically, those 3 dots replace the first line of the ECMAScript 5 code that we have above. And then the functionality is the same. So again, some syntactic sugar to make our lives easier, but we can simplify it using the arrow functions. Simplify it even more. So this again, tag and all the logs that we pass in, how many we want to pass, it's up to us. And then for each log, we just do a console log of it. So two instances of using arrow functions here, and suddenly when you show this code to somebody who's doing JavaScript now, he wouldn't believe you that it's JavaScript, but it's going to be the JavaScript that we'll be using in about a year. So it's going to be interesting. And just for completeness, let me prove it to you that it all works. So this is the ECMAScript 5 way, info and all the 4 messages. ECMAScript 6, the same. And the arrow functions also, as you would expect, all 4 messages printed with a tag. So, wrapping up, my conclusions from my journey into functional JavaScript. To me, trying functional programming turned out to be a lot of fun, because it was basically like rediscovering the thing that I do, because I've been doing it mostly procedurally, object-oriented, but turns out that you can do it another way. So it was like a newly ignited spark, and it made me interested in my career once again. It's also, in terms of JavaScript, it's a new way to look at the language, because what you have to know is that in its core, like from the beginning, Brendan Eich, who created JavaScript, was very impressed with some functional programming languages, and that's why from the start he introduced the function as first class, the closures, lambdas, etc., because he knew that those are powerful features. And JavaScript was unlucky that for the first probably 10 years that it's been used, it's been only used to animate some stupid images on the websites. And only when the book JavaScript Good Parts was released, suddenly people realized that, hey, we can use this language to do some functional programming. Who would have thought? It turned out that you can do really powerful stuff in JavaScript, and people are doing it. That's why Node came around. You can now write full stack applications in JavaScript on your server, on your client. You can have databases written in JavaScript. And that's, I think, the biggest reason that you can do it functionally. And you can do a lot with this language. So functional programming also is a nice way to stretch your brain muscles, because you have to think about different things than you think about when you do object-oriented, for example. So you reach the areas of your brain that are unused usually. So it's a nice exercise and a nice challenge, I guess, for every programmer. And on the practical side, to me at least, the biggest advantage is that it reduces the amount of code that you have to write. As I mentioned, read, reason about, debug, and maintain. So the less code, the less a problem you have when you have a bug on production and your boss is screaming at you and you've got 5 minutes to fix it. Also, the functional programming is concise, so code readability is improved. And this is an area that is very rapidly developing. You have all those libraries. I've just shown you a few, but in a moment I'll show you links to some other ones that are interesting, and I encourage you to check them out. And also the language creators, the ACMA Script 6 committee has been adding functional features, and they're already in the standard. And ACMA Script 7 will bring even more functional programming features, so there's some cool stuff that's going on, and will keep going on. So as I mentioned, those are the sources. Some sources of inspiration, this blog post, then LoDash and FunctionalJS that I've been showing you, some additional functional programming libraries for JavaScript, 2 very interesting books, JavaScript Along A, that you can read online on LeanPub, and also Functional JavaScript, which has been published by O'Reilly. I recommend both of them if you're interested in the topic. And finally, this shortened link to this talk and the code if you're interested, which I have put on GitHub. So we can use this shortened link to access it. And that's it. I would like to encourage all of you to leave some feedback, both to me as a speaker and the conference. There is it's available on Jointin. I'll also provide a shortened link if you want to just write it down. It might be easier. So I am waiting for your feedback because I want to make sure that I keep improving as a speaker. So I very much would like to speak to you later on during the day. And if you have questions, we can probably take a few now or take them outside. Any questions? Yes? Wait for the microphone.
So what do you prefer, LoDash with respect to underscore?
I really have no preference. When I started looking at this, LoDash was the cool thing, the new kid on the block, because there were some rumors that underscore is not maintained as it should be currently. So, but they're basically the same. I could do the code in underscore would look the same, I think. So no preference. Okay, if anyone else wants to talk, I'll be around. You can find me in the halls today in the venue. Thanks for attending the talk. Have a good lunch.